Okay, today we are looking at limits of infinity. Consider the function f of x is equal to 1 over x minus 2. Right. Consider the function 1 over x minus 2 right here. Well, I might ask you a simple question. Can you find the limit as x approaches 2 for this function f of x? Right? Can I find a limit? Well, the way we would work this limit out, at least try, is to use direct substitution. Now, when I use direct substitution for this function up here, what I end up with is 1 over 2 minus 2, which is equal to 1 over 0. Yes? And now I have an answer of 1 over 0. So is the answer to this limit does not exist? It turns out that when I have a number divided by 0, it turns out that when I have a number divided by 0, this right here is an indeterminate form.
Quick question. Is this a new topic? Did we go over this already? Is this new?
It is new.
Okay.
That's what this little right here, little thing right here means. Indeterminate form. Remember I said that there are several indeterminate forms and we'll see more of them as we go along. Again, what you have to do for indeterminate form is remember that we have not done enough work to get to the answer. Now, with this kind of indeterminate form here, the thing that we need to remember or understand right here is what to do next. In the previous examples, when I had 0 over 0, what we had to do was to simplify the equation and then try the limit again. Yes? In this form right here, when we have 1 divided by 0, the steps are different. In this form right here, I have to make there are two ways to get to the answer. One is to graph the function, and the other one is to use a table of values. We cannot simplify the problem and try again. That's not going to work right here for this example right here. And so we have to try a different method to get into the answer. In this case right here, there are two of them. Let's go with the first one. That's the graph. So I'm graphing, so I have axes going this way. I have axes going this way. And then, y'all remember how to graph this function from back in the day? No one is shouting, yes, I remember. I don't know if that's a good sign or that's a bad sign. So at the value 2, this graph will have a vertical asymptote. Do you remember vertical asymptotes? And this is a 1 over x graph shifted 2 units to the right. And so what you would have is you would have one boomerang surface right here. And then the graph will jump to the other side, and then it will go like so. And that would be the graph of the function right here. Okay. The behavior around the asymptote, so this right here is your asymptote A, is what we call asymptotic behavior, or another way of calling it is extreme behavior. As the graph gets closer to the asymptote, the graph gets higher and higher on one side, on the other side it gets lower and lower and lower. Yes? No?
Yes.
So now that I have the graph of the function, I can now determine the limit. And the way I am going to determine this limit is I am going to split this into two sides. I'm going to find the limit from the left, and then I'm going to find the limit from the right, and then I'm going to go from there. So the left side is over here. So the limit LIM as x approaches 2 from the left for my function, right here, I claim that is going to be negative infinity. Well, how did I get this answer of negative infinity, you might say? And I would say to you, what I am at is an asymptote. At an asymptote, I am seeing extreme behavior. If I trace or follow the graph on this side as I'm approaching 2, you can see the graph is going to go down forever. And if the graph is going to go down forever, the way we describe that in mathematics is we use infinity. And in this case, more specifically, I will use negative infinity because I am going down forever. Questions there?
No.
Okay, well then somebody tell me what's the limit on the right going to be as I approach 2?
Positive
Positive
infinity.
infinity.
That is right. As x approaches 2 from the right, getting close to an asymptote, this right here is going to be positive infinity. So, I am trying to answer this question right here. What is this limit? I know the limit from the left is negative infinity. I know the limit from the right is positive infinity. So can somebody tell me what the overall limit is going to be?
Would it just be infinity?
No.
No.
It doesn't exist, right?
It does not exist. Can somebody remind me why the correct answer is does not exist?
Because there's a jump.
Yes, there's a jump. Another explanation as to why it doesn't exist?
You can't
Because
divide
it
by
actually-
0.
No, cannot divide by 0. It has nothing to do with that at all. Remember, limits have nothing to do with the point itself. Limits has to do with what's happening on the left and the right side. Again, so anybody want to tell me another reason why it does not exist?
Because they're not the same. They don't like equal the same number thing.
Limit from the left, that's right, and the limit from the right are different. And if the two limits are different, then we say the limit does not exist. Questions there? Comments? Queries?
On the test, so we have to explain why something doesn't exist.
No, if you show me this is how you explain. You find it the two limits, left and the right limits, and then you can say, yeah, it doesn't exist. Okay.
Thank you.
Anybody else? All right. So that was the first way of getting to the answer. But remember, I said there were two ways. The second way to get to the same answer would be to use a table of values. So I am taking the limit as x approaches 2 for my function. So we've done this before. I need a number line. What comes at the center of this number line?
2.
2. 1 over is 1, 1 over is 3. This right here is 1.5. The next in line is 1.9. The next in line will be 1.99, right? On the other side right here, I have 2.5. Then I have 2.1. Then the next one will be 2.01. You know, so forth and so on. So with those numbers, I create a table of values. And in the table, 1, 1.5, 1.9, 1.99. Let's go 1.999. Let's keep going. 1.1, 2, 3, 4. And then on the other side, 3, 2.5, 2.1, 2.01, 2.001, 2.0001.
I have a question. So whenever we're using the table of values, we can't just do like 1.5, 1. We can't just do like the number, then 1.5, 1.9. You actually want us to do the 99 and then all the way up to the 4 nines. Is that we?
Remember, the explanation for this question is an iffy one. The technical answer is you have to go until you can figure out what the answer is. And so literally if 1.99 was enough for you to figure out the answer, that's good enough.
Okay.
But the more complicated the function, generally speaking, the more digits you need to get it to like for example, let's say the answer is 1.67.
Mhm.
Sometimes you need to go a few more decimal places so you can get that last 7. Okay, because 1.6 is not close enough to the answer. So it really is truly is a trial and error. But the more decimals you do, the more accurate your answer is going to be.
Do we have to know how to do it both ways?
Of course, yeah.
Okay.
If, for example, you have a calculator that cannot graph, then you have to use table of values, right?
On the test, is it okay if we just use one that we think is better for us, or are you gonna have questions just like use this way, that way?
No, I don't think I do that. But that's a good idea, though.
Let's no.
All right.
Okay, I just
All right, fine. I'm not going to do that. I'm not going to do that. Since you brought it up, yeah, I'm not going to do that. It was just find the limit, and then you choose whichever one you want. All right, so now let me pause right here, go back again. What the catalyst for all of this was a number divided by 0, right? Remember that. 0 divided by 0 is solved in a different way. Yes? So okay, for this indeterminate form, so I plug in 1. Let me plug in 1 because that's really easy to do. So if I plug in 1 into this function, that's going to be 1 over 1 minus 2, which is 1 over negative 1, which is negative 1. Yes? Aha. If you plug in 1.5, your calculator will tell you the answer is negative 2. If you plug in, I do encourage you when you go home and you're going over these notes to do plug them in. Don't just believe that because he plugged in, he got an answer and you can do it too. A lot of students have issues with plugging fractions into your calculators. Do practice. Okay, there is no substitute for that. And then negative 999, that's negative 100. Then this one's negative 1,000. And then the next one is negative 10,000. Right? And what we notice if we're looking at the y values right here, the y values are getting smaller and smaller and smaller and smaller, right? But it's not really slowing down, right? It's not getting closer to say 10,001. The next number in line is going to be 100,000. The next number is going to be 1,000,000. The next number is going to be 10 million, right? When we have this right here, so again, this is the left side right here. The limit as x approaches 2 from the left for my function, that's going to be negative infinity as the y values are getting larger, are getting really small, really big, I think. Again, really, really small. Yeah, about that. Questions there? I go back to the original problem right here. You know, I would have, say, negative 10 here and negative 100 here. Then the next one in line would be negative 1,000, right? Every time I plug in a number that's closer to 2, I get a number that's much smaller. On the other side, if I plug in 3, again, the answer would be 1. If I plug in 2.5, it turns out the answer is 2. And this answer is 10. And this answer is 100. And this answer is 1,000. This answer right here is 10,000. So again, on the right side, the limit LIM as x approaches 2 from the right for my function, this is going to be positive infinity. We got the same answers we had before. Therefore, the overall limit as x approaches 2 for my function will be does not exist.
okay. So the way that I think I'd probably be doing it on the test is a table of values. So like for your y values, when you get negative 10,000 and positive 10,000, if it's ever the same, like negative 7 or positive 7, is that the same thing? Like it does not exist? Is that the same thing?
Remind me, why is the answer does not exist?
I have no idea. I didn't understand it in the graph. So I'm trying to figure it out here.
The reason why the answer does not exist is, what's the answer right here for the right side? What's the answer?
Infinity.
What's the answer up here?
Isn't it because the right side and the left side aren't the same?
Exactly. They are not the same. That is why the answer does not exist.
Okay.
Okay? If the answers both infinity, then the answer would be infinity.
Okay.
Okay. That's my next example. Oh man, I gave away the chicken coop. Can I get my chicken coop back? But I'm paused by here. Any questions? Comments? queries, concerns? All right, so let's try another example. Oh, anyone still writing? That's lots of zeros. Anyone still writing?
No.
All right, cool. So example number 2. Let's say I want to find the limit as x approaches -4 of 1 over x plus 4 squared. Again, direct substitution. This is going to be equal to 1 over -4 plus 4 raised to the second power. It would be 1 over 0 squared. It's going to give me 1 over 0. Can I now say the answer does not exist? You know what? I can actually guarantee you someone's going to write on the test for me. Someone's going to say, yeah, oh, you can't divide by 0. It doesn't exist. What can...
Don't you have to try the problem again?
Yes, because...
Because it's indeterminate.
Exactly. I have not done enough to figure out the answer. I'm going to do table values first, just so you know you get some, because you see a graph, you know exactly what the answer is going to be. So, again, I am approaching -4. And so I'm approaching -4. So let me write that limit as x approaches -4, f of x. So that means I have my fancy number line. In the middle of my number line is -4. Over here is -5. Over here is -3, -4.5, -4.9, -3.5, -4.1. You've done this like 500 times, right? Because you'll just go home and you'll just practice math all the time, right? Because you'll love it so. And your dreams of your second major being mathematics. And so when you go in the business world, you have that leg up advantage over everyone else. And you say to yourself, you know, I can do the math. No, I don't have those dreams. -5, -4.5, -4.1, -4.01. Let's do one more. -4.001. And on the other side, I have -3, -3.5, -3.9, -3.99, -3.999. Have I lost anybody? I think it's a good.
Can you explain that step again?
Which step is that step?
From the number line. Is it the same way we've been doing it from the beginning of limits?
Yes, sir.
Okay, thank you.
So the limit is -4, right?
Yes.
So -4 goes to the center.
Okay, thank you.
Just treat it like a regular number line. So on a regular number line, -5 will be over here and -3 will be over here, right?
Yes, sir.
Okay. Just gotta remember, since it's on the negative side, things look backwards.
Okay.
That's all. So if I plug -5 into this function, the answer I get is 1. If I plug in -4.5, let's do that. So 1 over -4.5 plus 4 squared. Again, you have to be careful when you're typing this into your calculator. Use the parentheses like I'm doing them right here. That's going to be -0.5 squared. Yes? That's going to be 1 over 0.25. Aren't you glad you have a calculator? So you can just do this so quickly. And that's going to be 1 divided by 0.25 actually is 4. So this answer right here is 4. Again, same steps. I plug in -4.1. The answer is going to be 100. 4.01. The answer is going to be 10,000. 4.001. The answer is going to be 1 million. The next one is going to be 100 million. The next one is going to be 10 billion, I believe. Right. So on this side over here, on the left side, the limit as x approaches -4 from the left. What is that equal to? Don't you all tell me at the same time. Somebody tell me what that limit equal to.
Infinity.
It's going to be positive infinity.
Going to be positive infinity. All right, so what I need for you to do right now is to plug in the remaining half of the function on the other side. And then when you're done that right here, go ahead and send me a private message. What is the limit as x approaches 4 from the right of the function?
And you're plugging in the x's into the 1 over x plus 4 squared.
Let me write down for you. Yes, you're plugging the 1 over. So plug in the 1, 2, 3, 4, 5 numbers into the function, get the answers, and then I want the limit from the right. When you plug in 3 into this function, you get an answer of 1. When you plug in 3.5, you get an answer of 4. 3.9, you get an answer of 100, then 10,000, and then 1 million. Okay, if you got negative infinity, you have to watch your signs. When you raise something to the second power, it becomes positive. A number divided by a positive value is all, a positive 1 divided by a positive number in the denominator is always positive. And so this limit right here is also infinity. So the limit from the left is infinity and the limit from the right is infinity. So then what's the answer to the problem? What's this limit going to be?
Infinity.
Infinity.
The infinity. Okay, so although when I did direct substitution, I got 1 over 0, the limit actually is infinity. Now, if I was to, in the graphing calculator, number line, so at -4, this graph will have an asymptote. So it'll be having extreme behavior at this point right here. And then on the left side, the graph is doing this, right? It's going to 10, then, 100, and then 10,000, and so forth and so on. And then on the other side, the graph is doing exactly the same thing, going upwards. So the limit from the left for my function is going to be equal to infinity, and then the limit from the right is also infinity. So you can see the graph is giving us the same information, hence the same idea, the same solution. Questions there from those people who had issues or concerns? Concerns?
Can you scroll up a little bit?
That's good enough? I need some.
Yeah, that's good. That's good. That's good. Thanks.
Anybody else?
For the graphing part, how do you know that both sides are going up?
That's what I'm saying. My graphing calculator did it for me. So do I have a graphing calculator on here? I think I do. There you go. There you go. There you go. So in your graphing calculator, you hit the start plot. Get to clear, 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 clear. And then it is 1 divided by open parentheses. Was it x plus 4? Close parentheses raised to the second power. And then when I hit graph, like so, oh, I need to change, you can barely see right now, I need to change my window. So window, yeah, oh, I got this, -512. Let's go with negative 6. That's not -6. -6. That's max. Let's go with 2. And then the y min, let's go say -5. And y max, let's go with say 100. All right, and then hit graphic. There you go. And so you see right here, that's the graph of my function. I can't write on the screen, but I could. That at -4 right here, that's where the asymptote is, and you can see on both sides, the graph is going up. In fact, if I keep scrolling, see the graph is going to go up and up and up forever. Any questions there? Okay, cool. So, what's the moral of the story? What's the point of all of this? And the point of it all is that math is great. Okay. The point of all is whenever you have indeterminate form, so the indeterminate form of a number divided by 0 right here, the first point right here is you must either use a table of values. Oh, how do you spell off again? I forget. You must either use a table of values or a graph to solve. One, and then the second one right here is that there are only 3 possible answers. We've seen 2 of them so far. The first example, the answer was does not exist. The second possibility is infinity. Can anybody tell me what the last possibility is going to be?
Negative infinity.
Negative infinity. Okay, that's the whole moral of the story. If I take a limit as x approaches the vertical asymptote for a function, then there are 3 possible answers. It's either going to be positive infinity, does not exist, or negative infinity. Those are the only 3 possible outcomes when I am in that situation of number divided by 0. Questions there? Of course, the negative infinity would simply be an example where I have my axes, I have my asymptote, and then on the left side, the function is going downwards forever, and on the right side, it is also going downwards forever, right? So at that vertical asymptote, the answer is going to be negative infinity. Any questions there? Comments? Queries?
Can you move the screen up a little bit?
You meant to reverse time?
Yes, please.
Undo my handwriting.
I have a question. Professor?
I'm listening.
So you know how the graph for the first example we did, it was like it was on 2 different sides, like the lines, the curves, it was on 2 different sides. So like what's the difference? Like what makes it like that? And then what makes it like how the graph was at this example, how like they both like meet at the same like
The difference between the 2 examples was the power.
oh, because it's squared. All right.
Because it was squared, it's positive, so that means both sides are going in the same direction. In the previous one, the power was odd.
I got you.
Was odd, and because it was odd, on one side was positive, on the other side was negative. Right?
Right. And when, that means like, so if it was to the third power, then it would be the same way.
It'll go in opposite direction. One side down, one side up. Okay, but if it's even raised to the fourth power, for example, then it will either be both going up or both going down.
All right, I got you.
Anybody else? All right, so the title of this section right here was limits of infinity. When you're taking this kind of indeterminate form, that's when you get a limit where the answer is either infinity or negative infinity. Can you see right here? My answer for example 2 was infinity, right? That's how you get your examples of limits of limits of infinity.